Okay, well, welcome everyone to this first afternoon webinar where we have Dr. John Mason, the BAA's Publicity Officer, who will be telling us about a special image which has been released for the 30th anniversary of the Hubble Space Telescope. A couple of logistical announcements. We are recording this meeting and we hope to have a video published on the BAA's YouTube feed after the event. Unfortunately, the live feed I think is not currently working, but the recording will be available later. After John's talk, there will be an opportunity to ask questions. And if you would like to ask a question, if you look at the bottom of the screen, you'll see a button marked Q&A. And if you click on that, then you can send a message direct to John. So that's enough for me, I think. I'll pass straight over to John.
Thank you very much, Dominic. Well, today we're talking about something very exciting, the release of a special image by NASA, ESA, and the Space Telescope Science Institute to celebrate 30 years since the launch of the Space Telescope. It's incredible to think, you know, that it is 30 years ago, the 24th of April, 1990, that the Space Telescope blasted into space, safely stowed in the cargo bay of the Space Shuttle Discovery, which you can see taking off there. Once in orbit and various checks had been made, the telescope was gently deployed using the shuttle's robot arm into space and released into orbit. And here we see the Space Telescope in its operational configuration. The lid at the top of the tube there is open, so light can come down the tube and hit the main mirror, which is 2/3 of the way down the tube there. The main mirror, 2.4 meters in diameter. It then goes back up the tube to a secondary mirror and down again through a hole in the main primary mirror to the main instruments, which are all situated at the bottom of the tube there behind the main mirror to the right of the tube as we see it. Now, the reason for putting a telescope in space is very clear. When we observe objects in the universe from the ground, we have to look through our image distorting atmosphere. The atmosphere is always rather murky and it's always in constant motion. And this means that it blurs the fine cosmic detail. The universe itself is tremendously transparent, and light that has traveled millions, hundreds of millions, thousands of millions of years across space, that clear view is suddenly snatched away in the last microsecond before it reaches the ground. So putting a telescope in orbit like this enables us to get clear, uninterrupted views of distant objects and see a lot more detail in objects that we normally observe. Now here we can see the orbit of the Space Telescope around the Earth. It's the orange line there. So the telescope is 335 miles above the ground, orbiting the Earth every 95 minutes. And you can see that the Space Telescope's orbit is inclined to the Earth's equator. Now, the observations are made sometimes over many, many orbits of the telescope around the Earth. And this means that there has to be a very complex guidance system on the telescope, which enables it to lock on to a particular object and collect the light and other radiation from that object for as many orbits as are necessary to complete the observations that the astronomers require. Now, the telescope was never going to be able to last for 30 years or more without maintenance, repair, and in some cases, even the replacement of complete instruments. And so the telescope was designed to be serviced in orbit. And here you can see the telescope there sitting on a platform at the back of the Space Shuttle's cargo bay. And there were a number of these so-called servicing missions during the lifetime of the telescope. Here we can see two astronauts there working on the Hubble telescope. They would work in pairs, in shifts, and they carried out a large number of very complex and important tasks to keep the telescope in tip-top working order. The last of these servicing missions was in 2009, and there won't be another one like this because the space shuttle has now been retired. Now, during the 30 years that the Hubble telescope has been looking at the universe, it's rewritten the textbooks in just about every area of astronomy, astrophysics, and cosmology. And the thousands of images that it's taken have really given us completely new insights into the universe around, and the telescope has made many important discoveries and participated in many others. Now, in recent years, it's become the tradition on the anniversary of the launch of the telescope to release a special image. Now, 5 years ago, in April 2015, this was the 25th anniversary image, a beautiful view of a young star cluster in our own Milky Way called Vesterlund 2. Now, the cluster, Vesterlund 2, is about 20,000 light years away in the direction of the constellation Carina. And you can see there's a cluster of about 3,000 very young stars in the center of the image there. These stars are just 1 or 2 million years old. They're just beginning their lives as stars. Now, young star clusters like this are always shrouded in clouds of dust and gas, the very material from which those stars have formed. And so to get this remarkable image, astronomers had to combine observations with a number of the Hubble instruments to be able to pierce the dust and gas to show the cluster in beautiful detail. Now, young stars are very windy, and they push out strong stellar winds, streams of electrically charged particles, and lots of ultraviolet radiation. And this not only pushes away the material around it, it erodes the surrounding gas and dust. And a big cluster like this will excavate a cavern, if you like, inside the cloud of dust and gas from which the stars have been born. And here we're flying in to the Vesterlund 2 cluster, and we can see that cavern around the cluster. And you'll also notice there are a lot of these dusty fingers pointing in towards the cluster of stars. And these dusty fingers are made of material that is harder to erode away than the surrounding gas and dust. So a fabulous view there to celebrate the 25th anniversary of the launch of the Hubble telescope. So what are we going to see for the 30th anniversary image, and where is it we're going to go? Well, we're going to leave the Milky Way, but we're not going very far. We're going to a small dwarf irregular galaxy, a satellite of our Milky Way, called the Large Magellanic Cloud. There are two Magellanic Clouds, the Large Magellanic Cloud, which you can see here in this beautiful DSLR image taken by Stenek Barden from the ESO's La Silla Observatory in Chile. And it shows really well the intermingling gas, dust, and stars of the LMC. There is a small Magellanic Cloud that is rather further away, about 200,000 light years, but it's in the LMC that the 30th anniversary image has been acquired. Now, as we fly slowly in towards the LMC, right in the center there, you can see there is a pink blob. Now, that is a very large starburst region known as the Tarantella Nebula. The LMC itself, as I say, 163,000 light years away. We're now moving in towards it, and you can see the Tarantella Nebula in the center. But the area that we're going is over to the right of the Tarantella Nebula, an area in the outskirts of the LMC. And so now we are going to fly, courtesy of the Digitized Sky Survey 2, ESA and NASA and the Space Telescope Institute, we're going to fly in to the region we're interested in. Now, the curve is the Milky Way there, the disk of our galaxy arching across the view. And we're now going right in towards the LMC, and we're going to zoom in to the very spot in which the 30th anniversary image was acquired. It actually lies in the outskirts of the LMC. Closer and closer we go. And we're now going to see a pair of very different nebulae that are the basis of the 30th anniversary image. And there it is in all its glory. Now, this shows two very different nebulae in the LMC. The one at the top there, NGC 2014, a glowing pinky red nebula, and below and to the left of it, something quite different, NGC 2020. Now, NGC 2014 is a starburst region. The pinkish nebula is composed almost entirely of hydrogen gas. And the cluster of stars within that nebula are responsible for the characteristic reddish glow associated with the ionization of hydrogen gas. As the stellar winds and the ultraviolet radiation from that cluster of stars go through the surrounding gas, they strip the hydrogen atoms of their electrons when they come into contact with the UV radiation from the young stars, and when the hydrogen and their electrons recombine, they give out a very distinctive pinky red light. And that is what you're seeing there in NGC 2014. Now, here we can see a close-up of that cluster of stars and some of the surrounding gas and dust. And in a moment, we're going to pan away from the center of NGC 2014 to the second object that is the focus of the 30th anniversary image, and that is something very, very different indeed. It's the blue nebula coming in from the bottom left of the field of view. And this is NGC 2020. Now, this bubble-like cavity was naturally carved out of the gaseous material around, not by a cluster of stars, but by a single massive unstable star called a Wolf-Rayet star. And the Wolf-Rayet star is the agent for the ionization of the surrounding gas. But here, it's not the hydrogen gas that's being ionized, but oxygen. So as the oxygen gas is ionized by the UV radiation pouring out from that massive Wolf-Rayet star, it creates this very distinctive blue color that we can see there. And so there's a remarkable contrast between the ionized oxygen in blue light of NGC 2020 lower left and the ionized hydrogen gas in the starburst region NGC 2014, which you see at the top of the view there. So this is the wonderful picture that they have released, NASA, ESA, and the Space Telescope Science Institute, to celebrate the 30th anniversary of the launch of the Hubble Space Telescope. Just yet another wonder of the universe brought to us by Hubble. And there we are. And that image was embargoed until midday today, midday British time, that is. So I don't know, Dominic, if we have any questions, but if we do, I'll be very happy to take them.
That would be brilliant. As I say, if people want to ask questions, if you go down to the bottom of the screen, you'll see a button marked Q&A. And if you click on that, then you can type in a message.
We don't have any open questions at the moment.
So if you go,
we have one from Nick Hewitt, former director of the Deep Sky section. He will know about these objects probably a lot more than I do. Now, of course, he's asked a question that I can't answer, because I was not privy to the process by which they chose this particular object to image. It's interesting because the observations that they used to produce this image were actually made fairly recently, because I know when I spoke to the people earlier in April, they were still actually collecting the observations of this pair of objects to produce the 30th anniversary image. But as for the reason that they picked it, I don't know the answer. I'm glad you're not grumbling. I don't know the processes by which they choose these things, but they're a lovely pair of objects, and I think they wanted to show a contrast between the processes going on in a starburst region and obviously the processes going around a massive unstable star like the Wolf-Rayet star lower left. There probably, this is from Martin Crowe, there probably was hydrogen, there would have been hydrogen material originally, but I suspect that what's happened is in the earlier days of this massive unstable star, the hydrogen in the nebula has probably been pushed away, blown away, and we now have gas, and of course the radiation coming from the central star, very energetic. It's going to be energetic enough to ionize the oxygen atoms in what gas remains in the shells around the Wolf-Rayet star. A question from Chris Millington. The two NGCs presumably unrelated. Yes, they are both in the Large Magellanic Cloud. Of that we can be fairly certain. And I don't have the exact distances of the two objects. NASA released only very limited information prior to 12 o'clock today, and as a result I've only been able to go on the information that they gave me, but they certainly are both in the LMC. They are unrelated, yes, but they are obviously some considerable distance apart. Obviously, the Wolf-Rayet star, being a very massive star, is going to consume its available core fuel very, very rapidly. These incredibly massive stars use their available nuclear fuel at a prodigious rate. And so it's fast and furious, then they're finished. Lower mass stars, of course, use their available fuel in the cores in a much more parsimonious way, and they have much longer lifetimes. So we're looking at the Wolf-Rayet star during a relatively short time period of maybe a few tens of millions of years, whereas the lower mass stars that are being born in the starburst region, NGC 2014, some of those, of course, will live for as long as the sun. And now we have, as I say, question, I don't know the distance between the two nebulae, and they are both in the LMC, and they're obviously some distance apart. They're unrelated, but I don't know the exact distance is between them. When I find that out from the information released later today, we'll post something up on the website to give you. Now, a Wolf-Rayet star is, as I've said, a very, very massive class W star. These stars may be between 50 and in some cases maybe even up to 100 times the mass of our sun. Their lives will be very short and they will explode as supernovae. So in other words, the massive star we see lower left there, its days are numbered. In relatively short time in the cosmic scale, as it fuses ever heavier elements inside the core, we will get to the stage where we get a core of iron produced in the core, and then the game is up. The star explodes as a supernova, and then there will be obviously an expanding shell, a shock wave from the explosion that will push right through the material that was emitted at earlier epochs. And as a question here from Nick James, I do not have any technical details of the exposure at all. I don't even know exactly which instruments were used. As I've said, the information released before 12 o'clock today was very limited. I either had to show you the image as soon as I could after release with the fairly limited information I had at the time, or wait till later on this afternoon when I had more information, by which time it would be everywhere. So I chose the former rather than the latter. But again, any information that we find, we will certainly put up on the channel. There are always large format prints for distribution. You can basically usually download very large format images of all of the anniversary images, and you can print them out incredibly large. In fact, we have a version of this particular picture that is about 4 meters by 3 meters in the planetarium at the moment. A class W star is a special class reserved for Wolf-Rayet stars. So in other words, if you think of the Hertzsprung-Russell diagram, these stars would be at the very top left of the HR diagram. In other words, they are incredibly hot, high surface temperature, white stars, and very, very massive, very high luminosity. So upper left of the HR diagram. Do we have any other questions there? As I say, we will get, as more information is released, I will make that information available, and I don't know whether we can add answers to these questions. I think we probably can, but at some later time, we can add the answers to the certain things like the distances between them and the exposure details. I'm not sure they're going to give the reason why they picked these objects, but I will ask the question.
I guess we can certainly discuss that on the forum on the BAA website.
Yep, sure. Am I able to type answers to these at some later time?
I am not sure. I think this meeting will...
If I can, I can probably answer the people individually, or some way like that.
I don't think you can answer them after the webinar has...
Oh, okay. Okay, fair enough.
We've got a couple more questions.
Okay, so Mike Rushton. Yeah, now you're quoting the distances there, 160,000, 158,000. They are both in the LMC. Those Sky Safari Pro is just using certain catalogue figures. I'm not sure how accurate those figures are, so I wouldn't be certain that there really is a 2,000 light year separation between NGC 2020 and NGC 2014. But as I say, I will certainly try and find out, and we'll find out exactly what the details are. But as I say, the LMC is currently given as 163,000 light years away. Both of these objects are in the LMC, but I think basically as far as distances are concerned, within a few percent, the distances of NGC 2014 and 2020 are very similar. And thank you to Jane for the comment about the webinars. We will carry on doing them as long as we can. Callum is saying it would help if you could read the questions out, as we cannot see what other people are asking. I do apologise, Callum. I did not realise that everybody was unable to see the questions. I think I've, in my answers, said, given an idea of what the actual question was, but I didn't realise. So basically, Wolf-Rayet stars are, as I say, they have a special spectral type W, which is beyond O of the normal spectral classification. That was from Jack Martin. the spectral type of Wolf-Rayet stars. I say very, very hot, white, massive, highly luminous stars right at the top left of the HR diagram, and given generally the spectral class W, which is below, beyond O of the standard classification.
Well, I think that's all the questions we've had so far. If you've got any last questions, please do feel free to click on that Q&A button at the bottom. We've got a bumper crop of webinars at the moment. We've got another one tomorrow afternoon at 2:30 in the afternoon, which would have been the BAA spring meeting in Nottingham, but we're holding it online. We've got two speakers for that. Professor Simon Goodwin, who will be talking about Is There Anybody Out There? And the study of exoplanets. And that will be followed by Roger Dimmock, who is director of the BAA's exoplanet division, who will be giving an update on his section. And then after that, we have our next regular Wednesday evening webinar next week, when David Arditi will be giving us a tour of the moon in twilight, assuming the skies are friendly. If it's cloudy, then I think he will be using images that he's taken in advance. We've got one more question for you, I think, John.
I'll just go down to it. The question is, what are the widths of these nebulae? Now, again, I don't have any angular scale on the image that has been given to me. So we are talking about probably for the starburst region, we'll be talking possibly around 10 to 15 light years. And for the nebula around the Wolf-Rayet star, obviously a lot less than that. But as I say, I don't have any accurate image scale on these images. So if I did, then it would be possible, knowing the distance, to work out the angular size. But I can't at the moment have that. Those are my best guesses, that we're talking for the starburst region, typically 10, 15, maybe 20 light years, and obviously just a few light years for the nebula around the Wolf-Rayet star.
Well, that seems to be it for the questions, John. So thank you very much for giving us that fantastic image. And I guess some of the more technical details we'll hopefully find out in the coming hours.
I hope so.
Fantastic. Thank you very much, John.
Thank you.
I guess that's the end.
Thank you, Dominic, for stepping in at short notice.
That's no problem at all. And as I say, our next webinar is tomorrow at 2:30 in the afternoon, when we have two talks. So I hope to see many of you there then. Thank you very much.
Thank you.